Again, welcome to College Algebra. This is Inequalities. So our main topic today, again, is inequalities. Our main objective is to use the properties of inequalities, also solve linear inequalities and applications. Also, we're going to solve compound inequalities, quadratic inequalities, and rational inequalities. So first, we start with using the properties of inequalities. Our first property said if A is less than B, A is greater than B, or A is equal to B. All these three statements, always one of them have to be true. So again, A is less than B, A equal to B, and A is greater than B. Always one of these three statements, only one have to be true. So we say for any real numbers A and B, one of the following statements is always true if A and B are real numbers. Our second property is called a transitive property. And here we have three real numbers, A, B, C. Now here we say that if A is less than B, and also B is less than C, since A is less than B and B is less than C, then A also is less than C. Now, if A is greater than B and B is greater than C, again, A is greater than B and B is greater than C. So this means A is greater than C also. The reason why, because B is greater than C and A is greater than B, then A is greater than C. So this is our, again, transitive property. Next is the addition and also subtraction properties of inequalities. Here we say that we have, again, A, B, C as our real numbers. Now, if we said A is less than B, then A plus C should be less than B plus C. C will be the same value. So if A is less than B and I had the same value to A and B, still A will be less than B. So if A is less than B, then A plus C is less than B plus C. Now, if A is less than B, then also A minus C should be less than B minus C. Similar property again exists for greater, less than or equal, greater than or equal. So example, if A is greater than B, then A plus C is greater than B plus C. If A is greater than B, then A minus C is greater than B minus C. So again, this is our addition and subtraction properties of inequalities. Now we go to the multiplication and division properties of inequalities. Here again, we have three real numbers, A, B, and C. Our first part one said if A is less than B and C is greater than 0, then A times C should be less than B times C. The key here is that we have a C is greater than 0. It's a positive value. Now, if C is less than C, 0, now if A is, actually that will be the part 2. So if A is less than B and C is less than 0, then CA should be greater than CB. We are going to use a lot of this rule, especially this very rule in inequality equation. For example, if I multiply inequality equation with, let's say we have AS greater than, let's say 2s greater than 5. I'm going to use the values. 2s is greater than 5. Now I'm looking for x, so I can divide both sides of the equation by 2. So our answer will be s is greater than 5 divided by 2. We can see that the sign didn't change. Now, if I have negative 2x greater than 5, then I have to divide the equation by negative value. So this means negative 2 We'll cancel -2, and we are going to have 5 divided by -2. But now the sign will change. So instead of s greater than 5/2, it will be s less than 5 and -5/2. So that's the part 2 rule. Part 2 rule said if we are multiplying a negative value, we have to change the direction of the inequality sign. So if a is less than b and c is a negative value, it's less than 0, then CA, the sign will change from less than to greater than CB. Same thing applies for division. If A is less than B and I'm dividing by a negative value, C is less than 0, then A divided by C, which is a negative value, will be greater than B divided by C, which is a negative value. So we can see the sign change from less than to greater than. So now we know the properties of inequalities now, both addition, subtraction, multiplication, and also division. And also we went through the transitive properties, etc. Now let's solve our first problem here. Our first problem is solving linear inequalities and application. So we say that in linear inequalities are inequalities such as AX plus C is less than 0, or AX minus C is greater than or equal to 0, where A is not equal to 0. Now we are looking for the variable X. So if A is 0, it means X doesn't exist. So A can be any value, positive or negative value, but it cannot be 0. So now let's see our first example. Here we say we are solving 3 times s plus 2 less than 8. Again, we know parentheses means multiplication. So 3 parentheses open, s plus 2 parentheses close, less than 8. So the first thing we can do here, we can open the parentheses. So we can have 3x plus 6 less than 8. 3 times x will give me 3x. 3 times 2 will give me 6. We have a positive sign, so we keep our positive. Our symbol is less than, we keep it, and the 8. Now, when we look at this equation, we can use the subtraction rule. I have plus 6 here, so I'm going to use minus 6 to cancel it. So minus 6 to the left side of the inequality sign, and another minus 6 to the right side of the inequality sign. The goal is to balance the equation. So I'll get 3x plus 6 minus 6, 8 minus 6. Plus 6 minus 6 will cancel. 8 minus 6 will give me 2. Now here I'm going to use the division property. 3 times x, so I'm going to divide the equation by 3. It's a positive value, so the sign will not change. So we get 3x divided by 3, which will give me x. 2 divided by 3 will be 2/3. So finally, our answer will be x. X is less than 2 by 3, or 2 divided by 3. Or we can say 2/3. S is less than 2/3. So again, when we have a question like this, the first thing we do, remove the parentheses. Parentheses is a multiplication, so we remove it. Next step, we take the plus or minus away first before multiplication and division. So this means I'll use plus 6 to take, I'll use minus 6 to take plus 6 out. That's why we got 3x less than 2. Now I can take 3 out. 3 is multiplied, so I will divide by 3. Then our answer will be 2/3. So all numbers, what this means, again, we can see our answer means s is less than 2/3. So here we can say that this equation is good when any value is less than 2/3. Any value is less than. So we say all numbers that are less than 2/3 are solution of the inequality. So the solution will be, can be from -3, even from -infinity, all the way to 2/3, and that's what we have here. The solution set can be expressed in the interval notation as negative infinity to 2/3. And we can graph it in this form. Now let's go to solving compound inequalities. The whole concept of compound inequalities, you can see that in our previous example, we have only one coefficient and a variable, let's say 3x, 7x. But this time you can see that we have 3x minus 7, but instead of having only less than or greater, we are seeing two values between 3x minus 7. And so we call this concept or this as a compound inequality. 3x minus 7 should be less than or equal to 8 and also greater than 5. In our previous question, we said 3 times x plus 2 greater than 8. This time we have two inequality signs, so it's a compound inequality. Now, the steps to solve this problem is the same as the previous steps also. So first thing I'll be concerning, my goal is looking for the value of x. I'm looking for x. So the first thing I'm going to do here is to use plus 7 to cancel minus 7. Now, if I had 7 to 3x minus 7, then I have to add 7 to 8. Also, I have to add 7 to 5 to balance the equation. So here we get 5 plus 7, 3x minus 7 plus 7, then 8 plus 7. So 3x minus 7 plus 7 will give us 3x. 8 plus 7 will give us 15. 5 plus 7 will give us 12. Now we have 3x. We are looking for x, so we have to divide the whole expression with 3. So 12 divided by 3 will give me 4. 3x divided by 3 will give me x. And 15 divided by 3 will give me 5. So our final solution will be s should be greater than 4 and less than or equal to 5. So the solution of this inequality will be any value that is greater than 4 but less than or equal to 5. So the graph will look in this form: any value greater than 4 to 5, less than or equal to 5. Now let's solve a quadratic inequalities. So we have x squared. We know quadratic equation is a trinomial equation, trinomial, which means we have 3 terms. And the highest exponent should be 2. So this is a quadratic equation. X squared minus x plus minus 6 greater than 0. Again, x squared minus x minus 6 greater than 0. So the first thing I will do, we just write it as our regular quadratic equation: x squared minus x minus 6 equal to 0. Then we can factorize it. I can see that factorizing trinomial, I will look for two values that when I multiply, I will get -6. When I combine them together, I will get -1. We have negative x, so it's -1x. So this means I can use -2 and 3. So I'm going to write -3, sorry, should be -3 because our answer will be -1. So -3 plus 2 will give me -1. -3 times 2 will give me -6. So we again arrange it: s plus 2, s minus 3. The factors are plus 2 and minus 3. When you combine plus 2 and minus 3, you get -6. When you combine plus 2 and minus 3, you get -1. We went through this factorizing trinomial. So now I have two expressions here. So I'll take the first one, s plus 2 equal to 0. The answer will be s equal to -2. The second one, s minus 3 equal to 0. The answer will be s equal to 3. So our solution for now is -2 and 3. This is if we are solving equality. This is inequality. So we have to come back to our condition that our expression is greater than 0. So the best way to do this, we have -2 and 3. So the possible intervals we can have will be from -infinity to -2. Then -2 and 3, then 3 to +infinity. So those are our answer was -2 and 3. But the possible interval is we have -infinity, the lowest, and +infinity, the highest. So we can get from -infinity to -2, -2 to 3, -3 to +infinity. Now our next step is to take any value between those 3 intervals, and we're going to plug in to solve the equation, see if we can get it through. So first I have -8, -infinity to -2. We can take any value between. For example, I can take -3, I can take -4, any value. But we decided to test it with -6. Take any value within the interval -infinity to -2. We took -6. Now plug -6 into the equation given to us, which is s² minus s minus 6. -6 will be the x value. Then see if the condition will be true. So when we plug it, we get 36 plus 6 minus 6 will cancel. So we have 36 is greater than 0, which is true. So this means our interval here is a solution. Now the second interval is -2 to 3. We can take 0 or 1 or 2. We decided to take 0. Can take, again, if you even take -4 or any negative value between -8 to -2, you will still get true. Unless we take, let's say, -1. -1 is not in this interval. So right now, -1 should be in this second interval, which is -2 to 3, +3. So we decided to take 0, but also you can take -1, you can take +2, because those two values fall within -2 and 3. So we plug in the 0, we find out that our solution said -6 is greater than 0. That's false. So this means our interval -2 to 3 is not a solution. So it's false. The next one, we have 3 to +infinity. So you can take any positive value from 3 going. We decided to take 5. So we have 5² minus 5 minus 6 greater than 0. We have 25 minus 11, and that gives us 14. Yes, 14 is greater than 0. So we have 2 intervals that are true here, which is -infinity to -2 and +3 to +infinity. Those are our true interval values as we check. So that will be our solution. So we can see the graph here. Our solution is from -infinity to -2 and +3 to +infinity. Now, there's another method that we can use, which we said here, the method 2. A second method relies on the number line and a notation that keeps track of the signs of the factors of s² minus s minus 6. So we know first we factorize s² minus s minus 6 to be s minus 3 times s plus 2. So first we consider the factor s minus 3. When s minus 3 equal to 0, we get 3, as we saw earlier. Then we say that, okay, if s is less than 3, then s minus 3 is negative. If s is less than 3, then s minus 3 is negative, which is true. Because if s is, let's say, 2, 2 minus 3 is negative. If it's 1, 1 minus 3 is still a negative answer. But anytime s is greater than 3, then our answer will be positive. Next, we consider the second factor, which is s plus 2. And our answer was -2. So now we say that if s is less than -2, then s plus 2 will be negative value. But if it's greater than -2, then it will be positive value. So either negative when it's less than -2 or positive when it's greater than -2. Now we have those two values concept. Now we are going to test the sign. This is called construct a sign graph. We are going to test the sign with some few values. So we have s minus 3, s plus 2. So as we said earlier, s minus 3, we always going to get a negative value if s is again less than 3. So from -5 before 3, we have negative throughout. Then when it's 3 towards 0, from there to be positive values. Then when we tested s plus 2, we said that if the value is less than -2, then it's negative, which we did in the previous slide. So when it's -2, that's when we 0, then the rest is positive. Now, the only thing we are going to consider here is that the correct solution will be when the two factors have the same sign. So you can see here from -2 to -infinity interval here, it both is negative. From +3 to +infinity, everything is positive. So those are our two solutions. Here, s plus 2 is positive, s minus 3 is negative. So this is not a solution. So this is another way of solving the problem. So we have two methods of solving it. Now let's solve the rational inequalities. We know a rational equation means we have denominator and also the numerator value. So here our numerator value is s squared minus s minus 2 over s squared minus 4s plus 3 less than or equal to 0. Now, if they say we should solve this equation, it means we are looking for the value of the variable x. So the first method, again, we have two methods here. Let's look at the first method. The intervals are found by solving s squared minus s minus 2 equal to 0. Then s squared minus 4s plus 3 equal to 0. So again, we can factorize it. So when we factorize the first equation, we get -1 and 2. When we factorize the second equation, we get +3 and +1, which is true because we're going to get -1 and -3. -1 and -3, when you multiply, then you get +3. When you combine, then you get -4. But since we have s minus 1 equal to 0, s will give me 1. S minus 3 equal to 0, s will give me 3. So those are the two solutions for the two equations. Now the next step, we are going to establish the graph here to find the interval. So this solution will establish 5 interval shows in the figure. Again, we can see the interval from here. We have -1 to 2, 1 to 3. So what is the lowest value? The lowest value is -3. So my first interval, the lowest should be -infinity to -1. And we can see that here, -infinity to -1. Then we go to the next. Let's go back one. Oh, sorry, go back. Now we also have -1 and 1 here. So that will be another. Then the next lowest will be 2 to 3. Then the next will be 3 to +infinity. So just looking at the 4 values here, solution, we can set our interval. So we have from -infinity to -1, -1 to +1, +1 to 2, 2 to 3, 3 to infinity. Then the solution of the rational equality will be the numbers in one or more of these intervals. Now, to determine which intervals are solution, we test the number in each interval to see whether it satisfies the inequality. Here we didn't show the step. It's the same step we did previously. We have to check the sign, the plus, negative, and positive signs for these numbers. Then the ones that have the same sign, we choose them. And here it happened to be the 3 ones here. Negative infinity to -1, 1 to 2, and 3 to positive infinity. Again, this is the same step as we did in our previous question checking the sign. So we did it here. Now the intervals are 1, 2, 3, 4, 5. Well, so we can write the intervals here. Again, this is the same as what we did in our previous example, the same step. We write all the intervals, then take any value between the intervals. Here we decided to take -2, you can take -3, you can take any value that falls between -infinity to -1. We decided to take -2. Then use -2, plug it in the equation, the same as we did for the quadratic equation. For example, if I'm solving this problem, the question is s squared minus s minus 2 less than equal to 0, I'm going to follow the same step here. If it's rational, just substitute all the s values. So -2 will go to -2 squared, -2. We have another -2 squared down. So we substitute everything. Here we found out that it was false. 4 by 15 is a positive value. It's not less than or equal to 0. Then we do the next, the interval is from -1 to 1. The perfect value to choose is 0. So 0 gives us a negative value. So that's true. -2/3 is less than or equal to 0. That's true. Then we have 1 and 2. We decided to use 3 by 2. Again, you can choose any value you want. When we plug in, we get 5 by 3 less than or equal to 0. That's false because 5 divided by 3 is a positive value. It's greater than 0. Then 2 and 3, we choose 5 by 2. And we plug in, and this is true because when we did our calculations, we get -7 by 3, which is a negative value, so it's less than 0. And the last one, from 3 to positive infinity, we decided to use 4. When we plug 4 in, we get 10 by 3, which is almost 3.33. It's greater than 0. It's not less, so that's false. So we have only 2 truths, which is 1 and 2. So we are going to write our solution -1 and 1, 2 and 3. That is the ones that satisfy the inequality. The rest did not. And that will be our, again, the solution for this problem. So this will be the conclusion of our inequality equation. So in this section again, we went through the basic concept. We did each one example first, inequality properties. Secondly, we solved the linear inequalities. Then we solved the compound one. We solved the quadratic, and also we solved the rational inequalities also. With the rational inequality, I prefer this method. This is the method I always use. Again, the best way, first of all, find your intervals. And this is the equation. I will solve this, both are quadratic equations. So solve the first quadratic equation for the numerator, the second quadratic equation, the denominator. You're going to get 2 answers each, so 4. Now, if I have this 4, come up with the intervals now. So the intervals will be -infinity to -1, then -1 to 1, then we have from 1 to 2, then we have from 2 to 3, then we have from 3 to positive infinity. So we end up getting 5 intervals. Take any value within the intervals. This is the values we choose. Plug them in the equation, the original equation. and see which one are true. The ones that are true is your solution. The ones that are false is not your solution. So our solution was -1 and 1, and then 2 and 3. Those are the two solutions. So we have the solution here. So again, wish everybody the best. And if you have any question about the course, again, you can send an email or send a comment. Thank you.